In this video, we're going to look at using right angle trig to solve problems of angle of depression and angle of elevation. The first thing we need to do is look at what angle of elevation and angle of depression are. So the angle of elevation is shown in this first drawing on the left. We have a person looking up at a star in the sky. The person is located here. Their eyesight is following this line of sight up to the star at this point here. Label this point of where the person's looking starting as A and the object they're looking at as B. From the origin of the line of sight, we draw a straight line out, a horizontal line, shown here in a blue horizontal line from the origin of the line of sight out. The angle formed between this horizontal line and the line of sight up to the object. And again, the object is located above the horizontal line. This is called our angle of elevation, angle of elevation. So this angle here is our angle of elevation. So it's when you are looking up at an object, you draw a horizontal line out here. Your line of sight is drawn by this dotted red line. And you can drop your perpendicular here, the height from our B down to A, that height, and make our right triangle. So that's where our trig is going to come into play. Angle of depression is when you are looking down at an object or the object is located below the horizontal line. So again, we have a person here at point A looking down at a star, point B. The angle formed between the horizontal line and the line of sight down to the object is going to be referred to as our angle of depression. So again, our horizontal line is drawn out from the origin of our line of sight, where we're looking from, draw a horizontal line out, and the line of sight goes from where you're looking down to the object. Angle of depression is the angle between these two lines. And if we drop our vertical line down here from our distance A down to B, we get our right triangle. Let's use this and what we know of trig to solve some problems. We're always going to want to make a drawing when we start these problems to identify our triangle, our right triangle, and identify also what we're looking for. So we have this following example. A lifeguard is sitting in a chair at Hurricane Harbor looking down at a swimmer in the water. We'll put our lifeguard up here, point A, and we'll say this person is looking down at a swimmer in the water. So we'll just make the eyes here, they're just looking down, okay? If the lifeguard's line of sight is 10 feet above the ground, okay, so this is the line of sight right here, and it's 10 feet above the ground, so we can label this as 10 feet. And the angle of depression to the swimmer is 18 degrees. How far away is the swimmer from the lifeguard? Okay, let's see what we have here. Angle of depression. We are starting here. This line, this will be our line of sight down to the swimmer. I need to draw my horizontal line straight out from the origin of my line of sight. This will give me my angle of depression, the angle between this horizontal line and the line of sight. This is my angle of depression. And in this case, we're told that is equal to 18 degrees. So I'm going to go ahead and label that as 18 degrees. I want to know how far away the swimmer is from the lifeguard. Well, the swimmer, we can draw this line from this horizontal line down to the swimmer. We draw our vertical line down here. That gives us a 90-degree angle. And I want to know how far I am from the swimmer at this point here. Call that B over to A. That distance we can label as X. And I know I have my right triangle here. I am also given my 10 feet, which is going to be the same as 10 feet over here. So now I have a right triangle. I'm going to pull that out so we can see it a little bit easier. I have the following right triangle. Where this is A, this is my swimmer down here, and this is my point B I labeled here. I'll label my swimmer here as C. So I'm looking from A to C. I know this is 18 degrees, this is X, and this is 10. So if I think of this triangle, my right triangle in terms of SOHCAHTOA, I see that this is my opposite side, and this X will be my adjacent. So what trig, if we think of SOHCAHTOA, has the ratio of adjacent to opposite, and I know that that would be my tangent function. So tangent of 18 degrees is going to be opposite over adjacent. My opposite side is 10. My adjacent is X. I'm going to go ahead and put this over 1, cross multiply. I get X times tangent of 18 equals 10. I'm going to solve for X and get X equals 10 divided by tangent of 18 degrees. In order to solve for that, I'm going to have to use a graphing calculator, so I'm going to use Desmos. I typed in desmos.com. I click on graphing calculator. Since I'm dealing with degrees of the angles, I need to make sure I'm in degree mode. So I'm going to click on the little wrench in the corner, and I'm going to select degrees. So now I'm in degree mode. Go over here, I enter in my box 10, and I'm going to divide that by tangent of 18. I have to go down to my keypad, click on keypad to show my functions. I click on my functions, and I'm able to grab tangent of 18. And I can see that that will give me 30.8. So my distance is 30.8 feet. X equals 30.8 feet. So that is the distance from the lifeguard sitting in the chair to the swimmer. All right, let's move on to our next example. In this case, we have the angle of elevation from the bottom of a ski lift to the top of a mountain is 62 degrees. So I have the bottom of the ski lift. I already started the drawing here. This is the bottom of my ski lift, A. So this is my ski lift. And the top of my mountain here is B. It said the angle of elevation is 62 degrees. So this is my line of sight here between the two objects, and I'm looking up, so it is an angle of elevation. And my horizontal line is drawn here. So this is my right triangle. My angle of elevation is going to be given by my angle between my horizontal line and line of sight. So I was told that is 62 degrees. The vertical height of the mountain, let's go on to this piece. The vertical height of the mountain is 1,760 feet. So let's go ahead and label that. I know that's going to be this vertical height here of my mountain, 1,760 feet. What is the total distance traveled on the ski lift from the bottom, A, to the top of the mountain, B? So I want this distance here. This is going to be my X value. So in this case, my angle is 62 degrees down here. I am given the opposite, and I'm looking for my hypotenuse. So again, the trig function that deals with the ratio of opposite over hypotenuse will be my sine function, or so opposite over hypotenuse. Sine of theta equals opposite over hypotenuse. And in this case, I have 62 degrees. And that's going to equal my opposite side, which is 1760 divided by my distance X, which I'm looking for. So again, I'm going to solve for X. I get X times sine of 62 equals 1760. I divide both sides by sine of 62. Sorry, this one's not very clear. I get X equals 1,760 divided by sine of 62. Again, I'm going to use my graphing calculator to calculate that. I'm going to type 1,760. And I'm going to divide that by, I use my trig functions down here, sine of 62, and oops, and I can see that's going to give me 1,993.3 feet. So that is my final distance. X equals 1,993.3 feet. That's going to be the distance I travel up the chairlift from point A to point B. Okay, let's have a look at another one. In this case, we have a surveyor who stands 220 feet from a building to measure its height with a 5-foot tall theodolite. A theodolite is a piece of equipment often used for surveying. You've probably already seen this if you've been out driving or seen a construction site. You see someone there that is looking at the road and has sort of like a piece of equipment that is on a tripod type thing. So they have this tripod type feature thing with almost like a little telescope on the end of it or a device on the end of it. This is called a theodolite and it's used to measure angles. So the surveyor stands at 220 feet from the building to measure its height using a 5-foot tall theodolite. She measures the angle of elevation to the top of the building as 35 degrees. How tall is the building? All right, so we have a lot of information here. Let's start labeling our drawing. So I'm going to say that they're going to start looking right here at this point, and she's looking up at the building. Okay. They're told me that the surveyor stands 200 feet from the building, so I know this distance to the building is going to be 200 feet. Okay. The height of the theodolite is 5 feet, so the distance from the start of my line of sight down to the bottom of the building is 5 feet. And she measures the angle of elevation to the top of the building as 35 degrees. So if I'm looking up to the top of the building, this is going to be my line of sight right here. So I'm looking from point A to point B, the top of my building, and my angle of elevation is going to be the angle that forms between my horizontal line to my line of sight. So this is my angle of elevation. Angle of elevation. I'm told this is 35 degrees. How tall is the building? So I want to know the total height of the building. I want to know this total height. Well, if I drop this vertical line down here, I'm going to get my right triangle. And I'll just call this distance X. So this distance is going to be the distance from the start of my line of sight, the theodolite, up to the top of the building, this distance X. Again, I have a right triangle. I have my angle here, 35. I'm looking for the opposite side, and I'm given my adjacent side. So looking at my trig functions, SOHCAHTOA, opposite and adjacent is going to be tangent. So tangent of 35 equals my opposite side X divided by my adjacent 200 feet. I'm going to go ahead and solve for X. I get X equals tangent of 35 times 200. I'm going to go ahead and use my graphing calculator to calculate that. So I get 200 times, I want my functions, tangent of 35 degrees. 35. I see that I get 140. So my distance there is 140 feet. Again, that's this distance from the top of the building to the line of sight or the theodolite. That's 140. So I need to add my 5 feet here to account for the distance from the theodolite line of sight to the ground. So I'm going to add my 5 feet to that. And I'm going to get my total building height. Total building height is going to equal to 145 feet. Okay, let's do one more. Building A is 360 feet tall. Okay, I'm going to label this as I read it, 360 feet tall. Building B is 730 feet tall. All right, so I've got these two buildings. If the angle of depression, so they tell me right here, the angle of depression from the top of building B to the top of building A is 48 degrees, how far apart are the buildings? So I want to know the distance, how far apart these buildings are. That's what I want to know. The angle of depression is 48 degrees. So again, angle of depression, we're looking down at an object. So we're looking from building B down to building A. So I'm going to draw my line of sight going down there between the two buildings. My horizontal line always starts at the origin of my line of sight. I'm going to draw that across. Okay, since I'm looking down, my angle of depression is the angle that's formed between this horizontal line down to my line of sight. This is my angle of depression of 48 degrees. Sometimes people want to use this angle as the angle of depression, so be careful of that. It is not that angle. You have to start at your origin of line of sight, draw your horizontal line out, and this angle between the horizontal and your line of sight is your angle of depression, not this angle here. This is not the correct angle right here. This is not the correct angle. So now I have that. I know the distance from my building A to building B is what I'm interested in. So I'm going to go ahead and draw a horizontal up from building A to building B using this triangle. That's going to be, sorry, I didn't draw it very well, but that's going to be a right triangle. And I want to know this distance X, the distance between the two buildings. I can get this height by subtracting the height of my building B and the height of my building A. That will give me the distance between this point on my triangle and this point on my triangle. So let's go ahead and do that. So I'm going to take 730 minus 360, and I get 370. So this distance is going to be 370 feet. All right, now I have a right triangle. I have a right triangle with an angle and a side length, so I can use my trig functions to calculate the other sides of this triangle. So what do I have? I have the opposite side across from my angle, so I have my opposite, and I'm looking for my adjacent side. So if I have opposite and I'm looking for adjacent, I'm going to use my tangent function. So I know that the tangent of 48 degrees equals my opposite side, which in this case is 370, divided by my adjacent side, x. I'm going to go ahead and solve for x and put this over 1 and use cross multiplication. I get x times tangent of 48 degrees equals 370 feet. I'm going to solve for x. 370 divided by tangent of 48. Again, I'll need my graphing calculator. So I'm going to pull up my Desmos calculator, and I'm going to type in 370 divided by, go to my functions, tangent of 48. And I get 333.1. So my x value in this case is 333.1. So that is the distance between the two buildings, feet. That's my distance between the two buildings. So I hope those help. just remember, the biggest thing to remember is your angle of depression. If you're looking between 2 points, let's say we have A and B, your angle of depression is going to be the angle between the horizontal line and your line of sight. And your angle of elevation, if you're looking up from B to A, you take your horizontal line drawn across from B, and the angle that it makes with your line of sight is your angle of elevation. So I hope this helps. Good luck.